Hey guys, today we're going to be talking about a new interest of mine, which is kind of a subsection of artificial intelligence. So as you can see by the title of this video, I'm going to be talking about deep learning, which is kind of a subfield of machine learning, and machine learning is a subfield of artificial intelligence. So we went a little deep, but I dived into this and I've gotten really into deep learning and machine learning, at least like introduction wise. I'm no expert here, but I read a couple books that kind of talked about it, and then I just read more and more books. So basically, I'll give you a little background on my background here, and I have a mechanical engineering degree, and then I also have a math minor. So I took linear algebra and a few other electives outside of, like, I took, Calc 1, Calc 2, vector calc, and then I took linear algebra and a few other, like a proofing class and a couple other math credits to get the math minor in college. So I could follow along. There's a lot of linear algebra within machine learning and deep learning, so we'll get into that. But the main books that I'm going to be talking about is deep learning, so I have that guy here, and that's going to be the majority of our talk is from this MIT Press Essential Knowledge series. So this guy is a professor at MIT and wrote this book. And then how I actually was first introduced into machine learning is through a different book that I picked up at Barnes & Noble, actually. We know it when we see it. And so this says, what the neurobiology of vision tells us about how we think. And it was like one of the last chapters that brought up machine learning, and I thought it was very interesting. So I kind of picked up this next deep learning book, and then I started reading it, and it was absolutely fascinating. Very different from my field, which I like. You know me, I'm always trying random things and working on random skills, and this is my latest random skill of choice. And I really like this subfield. So here I have my library. So I'm in the book, so if you go to my library, I have tons of books here. And we'll scroll down to deep learning. So you click the book. I'm going to open as a page here, and then you can see I have the icon as the picture of the book. Deep learning. Subtitle, I just put that it was the MIT Press Essential Knowledge series because I'm reading through a few more of those books, so I want to be able to filter for that. Date read, so I actually finished it today. I have the image uploaded. It's either books to read, in progress, or complete. I have the author here, and then I also will put notes about the author, like where he teaches and things like that. Then I have the topic, so obviously I have computer science. And I'm not sure what other topics I could put. I could put artificial intelligence, but I haven't really read that many books on it, so I didn't know if I want to make that a topic yet. So first, I'm just going to go through what I've learned in the book. Now, there is some like heavy math partway through that I'm like, I don't have the effort to go and or the motivation to go back and relearn a lot of the calculus topics. I wanted more of a general overview. So I'm going over a general overview of artificial intelligence, machine learning, deep learning, mainly focused on deep learning as that is the title of the book. So I'm also going to read slowly because in this book I had to reread sentences because it can get very complicated. But I'm going to give you the general gist of what people mean when they're talking about machine learning and deep learning. So, deep learning. Okay, so this was the chapter. And I skipped some chapters. Like there was a history chapter, and I don't have the patience to learn the history of things. I really need to, though. So, I'm going to define a few terms as I go. Personally, I think people make terms to keep people outside of their field confused. So I like to try to dumb it down as much as I can. So deep learning, subfield of artificial intelligence that focuses on creating large neural network models that are capable of making accurate data-driven decisions. Okay, that was a mouthful. Basically what it's saying is that there's a model, and we'll get into the neural network part of the model, and they're going to make decisions based on historical data. That's the whole goal. Okay, so in order to make this useful, you need to have data that's complex. So you want to have decisions that are really hard to make, right? You don't want to just be doing decisions that are easy. Large data sets. You want to have lots and lots of examples because you have to feed it into your model in order to train your model. And we'll get into that. So what does that mean? Here's some examples. Facebook analyzing text conversations. Very complex, lots of data, right? Google using this for image search. Lots of data, lots of images. Very complex. Speech recognition, face recognition, processing medical images. So you could import a medical image and then it would tell you what kind of illness you have. Very complex. You would need to train it with large examples, right? That you know the answers to. Self-driving cars, gene predictions, spam filtering. So there's lots of applications here. So this is how deep learning is like in everything now. So let's go and see the difference, okay? This is how it was explained in the book, and I use almost this identical little circle diagram situation. Artificial intelligence, that's the whole thing. Inside artificial intelligence is machine learning. Inside machine learning is deep learning. So now I'm going to tell you the difference. Machine learning, the development and evaluation of algorithms that enable a computer to extract or learn functions from a data set or set of examples. So in order to understand what we're talking about here, you're going to want to know what a data set is. You're going to want to know what an algorithm is and a function. So here I have them written out, right? Data set table where each row, so you have rows and columns. The row is the example, so it's one specific example, and then the column is all the properties of that example. So if you were looking at like a loan applicant, you would have loan applicant 1, and then you'd have their debt as a column, and then their income as a column, right? And then you'd have loan applicant 2, and you have debt as a column, and you'd have income as a column. So it's just a table of data, right? Nothing to that. Algorithm, process, recipe, program that a computer can follow. So it's basically a set of rules. So it defines a process to analyze a data set and identify patterns in the data. Okay, so it's just process, no big deal. Algorithm kind of freaks me out. I don't know why. I think it's because all nerds use they say algorithms. I don't know, I feel my heart rate going up a little bit. I'm like, oh, I feel like I'm in unknown territory. Function, a mapping from a set of input values to output values. So you plug in an input and you get out an output. Nothing crazy there, okay? And I'll show you an example here in a second. And so it says, the goal of machine learning is to learn functions from data. So you're trying to extract patterns, right? One way to represent a function is to use a neural network. So keyword, neural, okay? You're thinking neurons, you're thinking brain. Perfect. That's all you have to know. It's a neuron. Neuron network, neural network, same thing. Deep learning is a subfield of machine learning that focuses on deep neural network models. Basically what they're doing is they're trying to mimic how brains make decisions, aka the neuron, and they're calling it neural network. Okay, so that's how you remember it. I was first introduced this when I read We Know It When We See It, which is this book here. And this was actually just supposed to be on neurobiology, and the last chapter was on machine learning, and I'm like, I've never heard of this. And that's why I started reading about it, because I thought it was very fascinating. So, a neural network uses decide and conquer strategy to learn a function. Each neuron in the network learns a simple function, and then the overall more complex function is created by combining the smaller neurons, okay? So, this is the picture. It was actually in this book, and then it was in this book, so here it is, right in front of us. You have inputs, which is all the inputs you give them. You have known inputs. And then you funnel them through like these hidden layers, and they'll decide which inputs are more important and all this stuff, and then you get an output. Like, okay, and you can have multiple layers, so each one of these dots is like a neuron, is kind of what they're saying. Okay, and I'm trying to be vague on purpose because this is very detailed, complex stuff. And I am more interested in the introduction, and if I want to learn details, I want to take a class, because I can't learn it through a book. I just can't learn math through a book. I can learn a decent amount of math through a book, but not the whole thing. I need a professor or a teacher or something. So here we go. A machine learning algorithm is a search process designed to choose the best function from a set of possible functions to explain the relationships between features in a data set. Okay, it's starting to sound a little too scientific for me. Here's an example. Function. So we all know what a function is. You input something and then you get an output. So if you, in a function, it's anything, right? We don't know what it is. We're trying to figure out what the function is. So let's say you input 5 and 5 into this function and you get out 25. You're like, okay, interesting. You put in 2 and 6, the number 2 and the number 6 in this function, you get out 12. You put in 4, you put in another 4, you get out 16. You're starting to see a pattern here, right? You're starting to see that this is multiplication. So what type of unknown function is this? This is multiplication. So great. That is literally what deep learning machine learning is trying to get out the function. Now this is an easy one. That's why you wouldn't want to use like neural networks to find this one, because a human can figure this one out, right? So this was straightforward. But as you increase the number of inputs and increase the potential functions it could use, the task is very difficult, right? So what the book says is there's 2 phases. There's a training phase and an inference. Okay, so the training, this is a machine learning algorithm processes a data set, chooses the function, so just like that multiplication, that best matches the pattern in the data, and then this is encoded into a computer program, and then that's referred to as the model. So it's kind of interchangeable, the function or the model, but they are different. The training process proceeds by iterating through the examples in the data set and updating parameters to get the best model, function, whatever you want to call it. Then you apply, and for that, you're using existing data. So you know the inputs and you know the outputs, right? And then you use that model once it's trained to predict, right? So then you're putting in new examples and you're getting out the value. That's where you don't know the output. But during the training, you know the outputs. That's how you train it. Okay, then there was some stuff about DevOps, MLOps, some simple definitions here. Don't know what that was about. The key ingredients to machine learning: data. You have to have historical examples. You need to know the inputs and the outputs. Okay, so if you wanted to train a program to read like a CAT scan or something and determine what kind of illness I have or what kind of tumor I have, you need to have a ton of examples where you know the output from doctors, right? And that's what you're going to feed it. Okay, a set of functions that the algorithm will search through to get the best match. And then some measure of fitness, because you need to evaluate it, you need to get an error and then go back and update the model, right? So they say there's 3 different categories of machine learning. You have supervised, unsupervised, and then reinforcement learning. Supervised is the most common type, and that's the one that they talk about in the book the most. And let's see, each example in the data set is labeled with the expected output value, so you know the output. You compare the outputs that the model gives you with the target outputs and then update the function or the model. Okay, seems reasonable enough. Unsupervised, for clustering data, no target values in the data set. Tries to map things into clusters, like categorize things, I believe. Didn't really talk too much about it in the book. Reinforcement learning, used for robot control and game playing. They learn a policy in order to get rewarded. Didn't really go much into that, okay? And then they say that data sets that contain large numbers of features are called high dimensional. Okay, that makes kind of sense. Okay, so then we get into this next chapter, and this is like the conceptual foundations. Okay, so deep learning network is a mathematical model that is inspired by the structure of the brain. We know that. Neurons, neural network. Obviously, it's inspired by the brain. Okay, so a simple function here, you have y equals mx plus b. Hope you remember that. It's a straight line. You have an input, which is x, you have an output, which is y. And your m and c are parameters, right? So he kind of shows an example by showing, okay, we want to know the solvency, which I've never heard of that term before, but apparently it's like whether you're worthy to get a loan or something. So income, you have your income, so that's an input. Income is an input. And then you multiply that by a weight of your income. So is the income more important to get the loan, or is the debt more important to get the loan, right? So depending on which one's more important, you'll have a higher weight on that income, or maybe you have a higher weight on your debt, because if you have more debt, then maybe you shouldn't be getting a loan. So it's a sum addition of the inputs times weights, okay? So this is known as a weighted sum, okay, makes sense. You multiply your inputs by the weights, and then you add them together. This is the basic calculation used in every neuron in a neural network. So this is the description here. So your weight is the W, X is your input. So you take your weight times your input. So depending on if that input needs a higher weight because it's more important than maybe this input, you'll have a higher weight here and a lower weight here. And then you have this weighted average formula. Okay, and that's just the line. Okay, no big deal. The general process for improving weights is to feed the input values from examples into the model, then use an error to update it, right? And then there's a decision known as activation. So for the loan example, you would put in your income, you put in your debt, and then let's say if your solvency was like above 200, you get the loan. So that would be your activation or decision rule, right? If it's above 200, you get the loan. I don't actually know too much about solvency. I'm just giving the bare bones of an example here. You can also graph these spaces. So you have the input space. You can plot what all the inputs you can put in. You can plot the different weights that you could put in, or the different weights that could be the weights for your neural network situation. You could plot the activation space. Like there's all kinds of plots that you can do. Don't get too hung up on this. Moving on, the next chapter goes into neural networks. So this is the building blocks of deep learning. So this is a family of network models that have multiple layers, simple information, known as neurons in the network, okay? Neurons, neural. So a little history on neurons, 3-part structure. You have the cell body. You have dendrites, which are these little guys. And then you have an axon, which is this long guy. So basically, you'll have incoming stimuli strong enough. The neuron transmit an electrical pulse, so you can follow this arrow, called an action potential along its axon. Bam, goes all the way down, and then the impulse goes into, and this will be connected to another neuron. And that's how signals are transferred. So it's very similar. So if you look at this kind of structure and you look at the hidden layers, you're like, okay, it's touching it. Imagine this as the axon, right? So you can kind of understand biologically how this is going down. The depth of the network is measured in terms of the number of hidden layers plus the output layer. So it's a very deep, this would be a very non-deep network. If you have multiple layers, it would become deeper, okay? Kind of makes sense. A neuron implements a 2-stage process to map inputs to an output, okay? First involves calculation of the weighted sums. So we saw the weighted sums formula. Then it's passed through the activation function. So that was like, if your solvency or your credit solvency is above 200, then you get the loan. So that would be your activation function. So don't get too hung up on this. This just means sum. The E means sum. So you have your weights, you have the weights times your inputs, then you add them all up, you get a number, and then you run that through the activation function. So you'll throw that in where X is. And then it'll do some fancy stuff, and then you get your output. Apparently, there's 3 main activation functions. Threshold, logistic, and tan-H, and then rectified linear units. Apparently, these have been like, they're kind of they've just come about through research, and there was a lot of history behind it, and it was a little too aggressive for my taste. I just wanted an introduction, so just know that there's 3 main ones, and I think they're in order. So I think they started with threshold, and then they went to logistics and TANH, and then rectified linear units. Okay, so you might be wondering, why are these needed? Apparently, to introduce nonlinearity, yeah, that's the word, to the complex network, right? Because things aren't just linear relationships. So let's see what it said. Neural networks, and in particular deep learning networks, are typically used to model relationships that are much more complex. Okay, these are more complex. Modeling these relationships accurately require the network to be able to learn and represent complex non-linear mappings. So not everything is linear relationships, it's not a one-to-one. So we need to bring in a non-linear part of the network. So neural networks involve vector and matrix multiplications, linear algebra. Hello, I've taken linear algebra, great. So I kind of understood that in here when they were multiplying matrices together. I'm like, fantastic. I actually can kind of get it. So like, I'm a little proud of myself that I was actually able to understand what this book was trying to say, because part of it was way too complex for me, but other parts I'm like, great. So apparently graphics processing units, which are GPUs, are designed to do extremely fast matrix multiplication. So they have been used a lot in deep learning. So now you're going to take your input layer, multiply it by the hidden matrix, and then you're going to run that through your activation function. Then you're going to multiply it by your output layer weight matrix, and then run that through another activation function. Don't get too hung up on it. There's lots of matrix multiplications. Apparently there's 2 different learning architectures. So you have convolutional and then recurrent neural networks. This is where I got completely lost. I'm not gonna lie. They lost me in some of this. So CNNs were designs for image processing, right? And it got, I kind of understood this because I read a book about how vision works. But basically you have one little guy will be in charge of one section of the picture, and then they do a bunch of this pooling, and then here's the ReLU, which we saw above, which are the rectified linear units. So there's something going on here. I don't think we need to necessarily know that. We just know that this one's for image recognition, and you have different areas of the photo that is responsible for certain cells or neurons. Then you have recurrent neural networks, RNNs. This is for sequential data. You only have one hidden layer, and there's some back propagation, which I based on this arrow and the fact that it's going back, I'm sure it's like feeding back something, right? Then learning functions, this got really complicated. Basically, you're training the network, trying to learn the function. You're searching for weights. The most commonly used algorithm is the gradient descent algorithm, and it updates the weights used in a function based on the error, so that makes sense, right? But this can only be used for non-deep, so you only have one layer, and this is due to the credit assignment problem. So how do you go back and tell which weight was causing the error, right? So if you have all these neurons, it's like, how do you know which weight of which neuron was messing with your output? Apparently they solved it for now by doing back propagation algorithm. I'm like, okay, you lost me here, but they fixed it, I guess. And so they randomly initialize the weights of the network and then update the weights based on the errors until it's working as expected. Great. And then the back propagation algorithm solves a blame assignment problem. So go back and I'll blame a couple of the neurons and fix the weights. And then bam, done. Obviously, I simplified it a lot because I did not understand a lot of the math. And there was a lot of like network architecture in here. And I was like, okay, we're a little deep. And then there's a last chapter about future of deep learning. And I found this thing, it said deep learning libraries, and it said TensorFlow and PyTorch. PyTorch. That sounds pretty cool. I'm thinking Pi is Python. I'm learning Python. Great. And then they started talking about this neuromorphic chip, which sounded kind of cool. And is potentially millions of low power units known as spiking neurons. So the brain is just being replicated everywhere. But I tried to go over this as fast as I can, but this was a really long introduction. But I hope that you at least learned something about deep learning. And I don't know how much further I want to go into this field. I really like artificial intelligence, and obviously I would want to take a class because I missed all the math part, but I feel like I got some foundational concepts like ready. So comment below if you have any other good books on these sorts of subjects. I'm learning Python, so I think that will help. And then I think I'm going to try a Udemy class, maybe with NumPy, and maybe more deep learning, because I think this might be fun. So anyway, link below anything that you suggest, and I will see you guys next time.